Friends, welcome to my channel. Dhanesh here.
Sentiment analysis is one of the most common applications in natural language processing. With sentiment analysis, we can decide what emotion a text is conveying or text is written. So that's what we analyze in sentiment analysis. You are familiar with that. See, this is the data set for sentiment analysis. I am using the sentiment labeled sentences data set. That is the data set name, and the data set source is UCI Machine Learning Laboratory. You can download the data set from this link. I can give you in the description as well for this link so that you can download the data set from this URL. Fine. Now the dataset info, this dataset was created with user reviews collected via 3 different websites: Amazon, YALP, IMDb. These comments consist of restaurant, film and product reviews. Each record in the dataset is labeled with 2 different emotions. Those are all positive. 1 is positive and 0 is negative. I will show you the data set. I have saved it in my system. I will know that data set only I am using it here. I will show you that as well. Softwares using here the NLTK, Natural Language Toolkit. You may be familiar, sklearn and Python. These are all the NLTK. Natural Language Toolkit is the leading platform for NLP using Python. NLTK provides libraries for classification, tokenization, stemming, tagging, etc. You can use a pip install in NLTK. Then you will get NLTK installed in your machine. If you are using Conda, you can use Conda install NLTK. You can use NLTK.download to download the dataset from NLTK. That is different. You need that as well, NLTK.download. So you will get a window like this when you use NLTK.download. See, the machine learning model. In creating the model, I am using the TF-IDF as the vector. TF-IDF algorithm, you may be familiar. I have a separate video on TF-IDF algorithm and its implementation, and the stochastic gradient descent algorithm as the classifier. Gradient descent algorithm and stochastic gradient descent algorithm. It's simple. Gradient descent, you take the whole data set, but stochastic gradient descent, you will take a small portion of that data set. That's fine. The TF-IDF algorithm, I am just giving a small idea. If you want more clarity, you can watch the previous videos on TF-IDF algorithm and its implementation. It's also known as word frequency algorithm. TF-IDF stands for term frequency inverse document frequency. This is a technique to identify a word in documents. We generally compute a weight to each word. Each word is associated with a weight, which signifies the importance of the word in the document and corpus. This is the math. TF-IDF is equal to term frequency into inverse document frequency. T is the term word, D is the document, N is the count of corpus, and corpus is the total document set. So a term frequency into inverse document frequency is the formula. I will tell you what is term frequency. Term frequency is measures the frequency of a word in a document. The formula is this: number of times term T appears in a document. T means a word, term word. Number of times T appears in a document divided by total number of terms in the document. That's what term frequency. Document frequency is the number of documents in which the word is present. That is document frequency. Inverse document frequency means the formula is logarithm of total number of documents. Here the base is E, log of to the base E, total number of documents divided by number of documents with the term T in it. That is the TF-IDF weight is the product of term frequency and inverse. This is what we consider. TF-IDF weight is the product of term frequency and inverse document frequency. You understood. Now I will get into the implementation part. See, I am first I will show you the data set. See, you can see here it is saved as Amazon, IMDb _ labeled, YELP underscore labeled. These three are the text files containing the data set. I have opened the text files as well. It's a huge file. It containing a lot of positive and negative sentiments. It's like, so there is no way for me to plug it here in the US unless I go. So it's a negative sentiment, 0. So it's see somewhere, great for the job on. Okay, 1. It is like good case, excellent value, 1. So it contains positive and negative sentiments. It contains all these three documents we are using. One is the IMDb underscore labeled and YELP underscore labeled. These are all the three documents. I am using it here for the sentiment analysis, and I have opened this YELP underscore labeled as well. The same thing, only it contains positive and negative sentiments, and you can see the IMDb label. It's so it's also contains the same thing. See, positive 0 and positive and negative sentiments. You can see it here. So how we will come up with the final analysis and prediction? That's what we see it here. It's pandas, NumPy, sklearn, NLTK. You can see here NLTK dot corpus dot stoppers. You can see here I am using the NLTK library, NLTK.corpus word tokenizer. Word tokenizer means, for example, it's the sentence is he is going to school. Then he is one token, is next token, going next token. Like that, we can split the sentence. That is the word tokenization. Here we are two tokenizers we are using. One is the regular expression tokenizer from the NLTK and the word tokenizer from the NLTK. That's what. See, even we are using the TF-IDF that we will I will import later. So this is sklearn like this. You can see the file here. See, input underscore file NLP Tatomasi NLP Python Amazon.txt is there. YELP underscore labeled.txt is there. Then YELP underscore labeled.txt and I see input file. After that we have read underscore CSV comma separated values we have converted. Then we are using the data frame from the pandas and we are printing the data. That's what we are going to do. Let me print the data. You can see the output in the console here in the right side bottom. You can see it. So I'm just printing the data. That's what I'm going to do now. See, you can see it. See, it's first 4 rows. After that it is 99. It's not able to print the entire data. It's a huge document, so just some portion of the data it's showing. It is around 3000 rows and 3 columns. It's having 3 columns and 3000 rows. It's a huge data. So we printed the data. Who is whether the data is stable, both the positive and negative emotions it is. That's what I am going to do here. See, I will run it. I will show you. After that I will see it is equally 50% and 50%. Both the positive and negative emotions, it's both 50 and 50. You can see it here. What I am doing is of details data group by. See, here I am trying to see the positive and the negative emotions by using a pie chart. I am printing it. See the count. I am seeing it, whether it's 50, how much percentage it is. That's what using a pie chart I am just showing it. So its data is stable. It contains equal positive and negative emotions. You can see it here. If you see this piece of code, we are using the regular expressions and the word tokenizer to pre-processing the data. That's what we are doing it here. You can see the code here. I am using the word tokenizer. It is word tokenizer. You are getting it from here. We have the word tokenize NLTK. From NLTK.tokenize you will import the word underscore tokenizer and regular expression tokenizer. So by using NLTK we can tokenize all these words, and we can see here also. You can see lower string. it is remove email address. So for that we are using this regular expressions. And to remove the IP address, those things we don't want. Remove punctuations and special characters. Remove numbers, for that we are using this regular expression. Remove stop words. See, to remove the stop words we are using this piece of code. Word underscore tokenized row sentence in this loop we are using the English. See, the stop words are different in different language from the English. The stop words, there are definite set of stop words are there in each language. When we are using English, for example, is or not, see, these type of words we call it as stop words. It doesn't make much significance, right? See, I am going to market, then see, I am going to market. See, that so the important thing is going to market. So that is, so other words we can avoid. I am going to market. So like that, see, we will remove all the stop words by using this piece of code. That's what here we are removing the email address using regular expressions, and remove the punctuations using the special characters using the regular expressions. That's why we are importing the regular expression tokenizer from NLTK, and we are removing the stop words from this. After that, again I am printing the data. You can see it here. Again I am running it. See, now again it will come. It will take some time. You can see it here. It will print. Here it is the distribution of the data. It's showing here. Now it will, after the pre-processing, we will get the data. It's see, it's again printed. See, if you see, you can see it here. If you want to understand it clearly, see, if you see here, this is the sentence. So there is no way for me to plug it in here. See, you can see there. See that one, how it is changed. We plug us unless go convert. See, like that it is changed. So the other words are stop words. See, there is, so those things it's removed. It doesn't make any significance. See, it's changed. See, good case, excellent value, good case, excellent value, unnecessary stop words and punctuations, email addresses, IP addresses, numbers, everything it is removed. You can see the difference. It's really interesting. These things, it's really interesting. I am making it large. If you analyze the data now after doing the text pre-processing, you can see it here. Most of the stop words it's removed. See the last part, for example, then as if I hadn't wasted enough of my life. This part you can see here, this thing. So after removing the stop words, you can see here this sentence like that, hadn't wasted enough life. So all other stop words it's removed from the text. See, that's what we are doing it by using this piece of code. That's all NLP project. Most of the NLP projects, this is the steps we follow. We first analyze the data, the distribution. We have the life cycle of an NLP project. We have the separate video. Then after that we will do the text pre-processing, and that's an important part. There only word tokenization, and we have this piece of code. You can see it. I will enlarge it here. You can see it here. So this is x underscore train, x underscore test, y underscore. See, it is we are this here by using this piece of code. We are trying to create the model, and we will try to train it. So that's what we, from this piece of code, we will do. This is a familiar piece, and we use it here to train it and give the prediction. See, you can see I am importing the TF-IDF vector. See, this is TF-IDF vector. That is from the sklearn. I am using we have the confusion matrix also, because I will print the matrix as well to get you more clarity. We are using the accuracy score, F1 score, everything we will try to print it. Scale dot matrix, accuracy score, F1 score, everything. And this is the SGD classifier, stochastic gradient classifier, that we will use to for the classification. So we are using the IDF vector and the stochastic gradient classifier to uh, to train and predict for the training and prediction. And here we are doing the prediction by using the classifier. After that, you have the sklearn and the accuracy score, and here we will print the model accuracy and the prediction. So that's what it's a simple program only. It's a very easy to understand. Let me run the piece of code and I will show you this portion. I will make it like this, so that you can see it here. I will run it. Then what's happening, let me see. Now the data distribution is shown. Now it is the model is training, and it is trying to do the prediction. Let's see how it's going. It will take some time, please. Yeah, see, we got we got an accuracy of 0.91. See, previously, last time when I ran the program, while it was running, it is giving only 0.90. See, it is, it's increasing. The accuracy became 0.91. Here you can see the precision, recall, F1 score, support. We are printing all this, you can see it here. We are printing the model accuracy and the accuracy score from sklearn. We are getting the accuracy scores as well, and the cross value score and the confusion matrix, everything. See, these values we got it. See, you can see here we imported precision score, recall score, everything, and the classification report. And after that, we are trying to predict the model accuracy and the classification report. That's what we could see here. Accuracy, it is we got a model accuracy as 0.91. It's a very nice thing. We got an accuracy of 0.91. It's really good. And we got F1 score for 0. It's a negative sentiments. We got the F1 score as 0.90. And for the positive sentiment, we got the F1 score as 0.91. That's also good. And the recall, it is 0.92 and 0.90. For the positive sentiments, it's 0.90. And for the precision, we got for negative sentiments it's 0.88, and the positive sentiments it's 0.93. You understood? Now matrix as well. So this piece of code, if you analyze, it's very interesting as well. See, I am here we got the precision. After that, we are importing enter tools. This enter tools, and I am writing a method plot underscore confusion matrix. For that, we need this enter tools and normalize title confusion matrix, and this function prints and plots the confusion matrix. Normalization can be applied by setting normalize true. So that's what we are doing. If normalize, and we are writing the here we will write the piece of code to print the confusion matrix. All those code it is used to print the confusion matrix. So we have after that y underscore test and prediction comma classes, set the print options, and after that we are printing the confusion matrix by using this piece of code. So plot non-normalized confusion matrix. See, here we are it is a non-normalized confusion matrix we are trying to print by using this piece of code. See here you can see the normalized confusion matrix. If you want the normalized confusion matrix, it's printing here. So that depends. If it is normalized, it will print here. Let's see how it goes. We got this. Now it will take some time to train the model and get it printed. Let me see. See, we got the confusion matrix without normalization. See, whatever we got is the without normalization. This is the confusion matrix. Here I will make it even larger. I will enlarge this so you can see it more clearly. See here you have the scores. You have it everything. Then the category 0, 1, index 1, 2. Then you have the confusion matrix with the predicted label. It's in the this x direction. Here you can see that if you see it very clearly, you can see this number 149. It's it's very, you need to be see here. I can in the right side, that value also it's written here. See, you can see it here, 149. That's the value of the here in this area as well, the top portion as well. You can see that value, it is not visible. We need to we cannot visible in this. I think if we are trying it in say a different ID like Jupyter Notebook or something, I think it would be much better. See here the value, it is 149. It's very clear. Here it is this top portion, it's not coming. Anyway, it's printing. It is printing properly. It's this is the confusion matrix for that, and we got the accuracy as 0.91, and the precision, it is for the this model giving a precision for the negative sentiments, it is 0.88, and recall 0.93, and effort score 0.91, and for the positive sentiments, it is precision 0.94, recall 0.90, and effort score 0.92. It's really good. It is it's really good. And that's all about sentiment analysis using NLP. Thanks for watching. Thanks a lot.